Hello everyone! Just right after you have gained some programming experience and have assembled several working devices on a breadboard, you may want or need to place everything on one printed circuit board. In this video I will help you go through the entire process of designing a printed circuit board from scratch. Before starting development, it is necessary to lay down all possible functions of the device, and based on this knowledge, select the element base. In most cases, the datasheet will contain connection diagrams, recommended topology, and calculation equation for all selected microcircuits. Thereafter, we will need a tracing environment, of which I chose a very convenient and free EasyEDA environment. In addition, it has access to the radio component warehouse database directly from the application. Provides the desired functions of the device. Autonomy is realized by battery power supply circuits, as well as battery changing and protection circuits. Wireless communication realized by the LoRa circuits. Information output to the screen OLED SSD 1306 is used. The ability to process keystrokes, a homemade Leshy keypad, acts as an input device. Connecting analog sticks, for now I use variable resistors. STM32F103 was chosen as a control device due to the accumulated experience of working with this particular microcontroller. Such microcontrollers are installed on Blue Pill. Many people use them, so there should be no problems. I will say right away that we will not consider the software part of the Palionish device. I wrote the program before I started to produce the PCB layout. Assembled everything on a breadboard with wires. I consider the result to be negative, but a negative result is also a result. The circuit is powered by a battery or a USB-C power supply. The circuit is powered from the outside by a USB-C power supply. There is a current limiting resistor R30.5 ohm here. Or the circuit can be powered by a lithium-ion 21700. The connector is here. The battery charging circuit from USB-C is provided by the TP4056 circuit. The charging current is programmed by changing the value of resistor R3. I have 2 kΩ. Protection against overcharging and over-discharging, as well as the short circuit, is implemented on the FS312. The circuit disconnects the battery from the load when the voltage specified here is exceeded or decreased. The circuit also monitors the current through the FS8205 transistor switch. If the limits are exceeded, it disconnects the battery from the load. The power supply for the entire digital circuit is implemented on the buck boost converter TPS63020. The typical connection diagram from the datasheet are not suitable for us, because in addition to this converter, stabilizers are used, in which the voltage also drops. Let's open the datasheet for the MCP1700T stabilizer. Here you can see the maximum voltage drop of 250 mV, of which it will not drop by 250 mV. Well, 200 mV must be included so that the voltage from the stabilizer output does not drop below 3.3 volts. The datasheet for the TPS63020 provides connection diagrams, but they are not quite suitable for us. As you can see here, the output is 3.3 volts and we included 3.5 volts. But in addition to typical diagrams, the datasheet provides equations for obtaining the required feedback resistances. I will add a file with calculations to the archive. I will highlight some parts of the datasheets that are of interest of calculating the feedback divider. The typical current into the FB pin is 0.01 microamperes, and the voltage across the resistor between FB and ground R2 is typically 500 millivolts. Based on these two values, the recommended value for R2 should be lower than 500 kiloohms in order to set the divider current at 1 microamperes or higher. It's recommended to keep the value for this resistor in the range of 200 kiloohms. Also in the datasheet for TPS63020 there is an example of tracing. Well, I will tell you that professional PCB tracers prefer to rely on their own knowledge and experience in tracing. It is due to the fact that often in the datasheet the wrong diagrams are given. On the topic of tracing, I recommend watching lectures by Rick Hartley, Eric Bogatin and other experts. Well, I repeated the diagram from the datasheet. The diagram can be turned off TPS63020 by connecting the EN pin to ground, which I have implemented using a toggle switch. The circuit uses three stabilizers. First, powers the digital part of the STM32. Second, the analog part of the STM32. Third, the LoRa SX2078 radio module. The digital part is powered separately in order to minimize digital high frequency interference on the analog and radio frequency circuits. The analog part is powered separately in order to reduce power supply interference associated with high-frequency power supply pulsation from the power supply circuit. The digital part of the STM32 and radio frequency oscillation from the LoRa circuit. For the same purpose, the LoRa has its own converter for power supply. I soldered the ready-made module. I just entered SX2070H into the search for the radio components and found a ready-made module, for which there is a 3D model. Note that the contact paths for soldering are marked. Of course, you can read the datasheet, but there is little information here. To get information on the chip, you need to look at the datasheet from Semtech. There is a lot of useful information on this circuit. It is not the topic of this video. I have a number of videos on the topic of LoRa and its programming, of which I will leave the links. If the power supply circuit could be called the heart of the device, then its microcontroller will be called the brain. You can see quite detailed information about the inclusion of the microcontroller in DC5319. As you can see from the circuit, a capacitor is connected to each power input. In addition, the ADC power supply circuit is shown here. Also, in this datasheet are the circuit diagrams for connecting quartz resonators, and a link is given to a document describing the calculations of a quartz resonator. We will not do the calculations of quartz resonators in this video. For such calculations, it is necessary to carry out precise measurements, and I do not have an oscilloscope probe for such measurements yet. We will probably calculate and make a low capacity probe in the following videos. I first made the connections of the remaining terminals using terminal using CubeMX to determine which terminals will be used for various peripherals. After that, I set these connections in the schematic diagram in EasyDA. Also in AN1709, starting from paragraph 4, there are recommendations on how to achieve EMC and example of correct and incorrect routine. I recommend you read it. In AN2834 recommendations for using ADC are given, as well as methods for increasing the accuracy of the ADC. It will be difficult to trace a printed circuit board without the appropriate knowledge. In the description I left a number of lectures on tracing which I recommend for review. The power bus tracing is done with a thick conductor. It is done in order to increase the bus capacity. The microcontroller is powered through these pins, and here is the output to the leg. In general, this is not recommended. It is recommended to place power capacitors along the path with the lowest inductance, and vias have inductance. It was not possible to place them closer, but there are little spaces on the upper layer. In addition, my analog circuits are placed on a separate layer, between two layers of ground. This conductor is used to read the battery voltage. Regarding the antenna output, to increase the transmission efficiency, it is necessary to calculate these sections from the output of the radio module to the antenna input. The impedance of this track should be equal to the impedance of the antenna feeder device. Usually 50 ohm is used. Regarding the tracing of quartz resonators, AN2867 has example of correct and incorrect routing. I did the routing according to this example. In addition, there are recommendations for choosing a resonator with different load capacities, depending on the operating environment. I think we'll be able to make a working printed circuit board with STM32. Thank you, subscribe to the channel and turn on notification. Until next time!